Hello children, today we will discuss about center of mass. The very important concept is a point of the body which behaves like a whole mass is concentrated on it. For example, if we take a rod of uniform mass is distributed uniformly. There is a point in it that point behaves as if whole mass is concentrated there. How can we know about it? For example, if we hang this rod to this point, this rod will be balanced, this rod will be in equilibrium. So I can say this point is behaving as if whole mass is concentrated there. If I take another point and attach this rod, suppose करिए ये point से attach कर दिया, it will not remain horizontal, it will come down. So I can guess from these two situations that definitely there is a one point in every body which acts like a whole mass is concentrated there. So today our topic is this one, center of mass. Now how to find its position? Okay. On the basis of experiments, it is discovered that if we take many points of mass m1, m2, m3 and so on, many points are there. Let us take many point masses, mass m1, m2, m3 and so on. Due to these point masses, there is a point which exists as in this rod, which behaves as if whole mass is there. Suppose coordinate system, x-axis, y-axis, coordinate of m1 x1, y1, z1, coordinate of m2 x2, y2, z2 and so on. So position of comb, x coordinate of the comb is given by relation m1 x1 plus m2 x2 plus and so on mn xn divided by total mass of the system. Similarly, y comb and z comb, m1 y1 plus m2 y2 and so on plus mn yn divided by total mass of the system. Similarly, z comb Zn divided by mass of the total mass of the system. Clear? If the body is continuous, it is like rod. In that case, x comb can be written as integration x dm divided by integration dm. Similarly, y comb y dm divided by integration dm. Similarly, z com, okay, for the continuous bodies, what is x here? X is x coordinate of the center of mass for dm element. Dm is element of the mass for the continuous body. Clear? Now, let us apply these two formula to find center of mass of 2 point masses m1 and m2. Let separation be d. Center of mass suppose करिए at this position C point. Let this point be origin. We can take origin, it is our choice at any point. X axis, y axis. Suppose that distance is d1, it is d2. So d1 plus d2 is d. C point is origin. Coordinate of m1 will be minus d1, 0. It is d2, 0 in 2 dimension. So x com will be equal to m1 into minus d1 plus m2 into d2 divided by m1 plus m2. But x com is 0 because I have taken center mass as origin. So this will be 0. So you can write it minus m1 d1 plus m2 d2 divided by m1 plus m2, or you can write m1 d1 equal to m2 into d2. Clear? And d1 plus d2 is d. So you can calculate easily d1 and d2 from these two equations. If you solve them, you will get d1 equal to m2 over m1 plus m2 into d. Similarly, d2 equal to m1 over m1 plus m2 into d. Clear? Okay. Now one very important thing is here. If m1 equal to m2, then d1 equal to d2. It means com is midpoint. So com is midpoint here. If m1 is 4 times of m2, suppose करिए m1 is 4 times of m2, then if you apply this equation, so 4m2 into d1 equal to m2 into d2, you will get d1 equal to d2 over 4. Clear? d1 equal to d2 over 4. So d2 is large, means that distance will be large. It means center mass will be nearer to m1. और यहाँ से कैलकुलेट कर सकते हो सीधा. m1 is 4 times m2. m1 is 4 times m2. 5. It is d by 5. m1 is 4 times m2. It is 4d by 5. So it's a d by 5, means In case of m1 is 4 times, it is 4m, it is m. In this case, center mass is nearer to the larger mass. It is d by 5, it is 4d by 5, when separation is d. So, from this very simple example, one thing is clear: center mass is nearer to the larger mass, and center mass in case of 2 points lies on the line joining them. If these masses are same, then center mass is at the midpoint. I would like to connect this example with the uniform rod. In case of uniform rod, you can see, if we consider it is made of infinite points because it is uniform distribution of mass, some mass is here, its equivalent mass this side by symmetry. These are two equal masses, their center mass will be the midpoint. Similarly, I take another element here, its symmetrical element this side, which will behave like a point mass. Center mass of these two will also lie there. In this way, I consider this rod made of symmetrical equal masses, and by using this formula, I can guess easily the center mass will be at the midpoint. If it is not uniform, then center mass will shift toward the larger mass. Okay? Now let us discuss next. Let us find center mass of the cone in which mass is distributed uniformly. Clear? Okay. It is cone, uniform mass is distributed in it. Let its vertex be origin. It is x-axis. Axis of the cone is y-axis. To find its center mass, we have to take element. So, element is part of the cone of thickness dy, normal to the axis. Normal to the axis, very small part of the cone. That part will be a disc of thickness dy of radius r. Clear? And center mass this disc will be at the center of this elementary disc, and that point is on the axis. It is center mass of this element. Now, y coordinate of the cone of the whole body will be equal to y dm integration dm. Y is the coordinate of center mass of the element. Element is a disc, very small disc, elementary disc. Its center mass is y. Now dm, mass of this element, मान लीजिए rho be the mass per unit volume of this cone. So dm will be rho into dv. dv is the volume of this elementary disc. Clearly, dv will be pi r square into dy. Now, if you take tan theta equal to r divided by y, so r equal to y tan theta, so you can write dm equal to rho into pi into y square tan square theta into dy. It is dm. Okay. Integration dm, total mass, this will be rho into pi into tan square theta rho into pi into tan square theta integration y square dy. So this will be equal to rho into pi tan square theta integration limit will be 0 to h y square dy. Now integration dm will be equal to rho into pi tan square theta y square integration is y cube by 3 0 to h. This will be equal to rho into pi into tan square theta upper limit minus lower limit. This will be equal to rho into pi into tan square theta into h cube by 3. It is total mass of the cone. Now for y com, let us separately calculate numerator y dm. This will be dm is rho into pi tan square theta into y square, because y dm this will be y cube into dy limit 0 to h. This will be rho into pi into tan square theta integration of y cube y 4 by 4 0 to h. Now if you simplify it, you will get integration y dm equal to rho into pi into tan square theta h 4 over 4. Okay, we have calculated numerator, we have calculated denominator, then position of the cone y com in this case will be rho into pi tan square theta h 4 by 4. It is integration y dm divided by integration dm. We have calculated here. It is total mass. It is rho into pi tan square theta h cube by 3. It is cancelled. So this will be 3h by 4. Clear? So position of the cone is solid cone, mass per unit volume is given, uniformly distributed mass in the cone from the vertex on the axis of symmetry. Center of mass is at 3h by 4 distance away from the vertex. From the center of the base, you can say it is h by 4. Now you can check one property of center of mass. It is nearer to the larger mass. Clearly near the vertex mass is less. It is increasing toward the base, so it is nearer to the base, clearly h by 4, and away from the vertex where mass is less, that is 3h by 4. Clear? Let us discuss one important concept in case of center mass. If some part from the body is removed, the center mass will change. It will shift toward the larger mass. So today my topic is, if we remove some part of the body, how the center of mass will shift. Okay. Suppose it is any body, center of mass is here. We are removing some portion from it. We have removed it. Then center mass will shift somewhere here, C dash. So look carefully. The complete body has center mass at that position. After removing some part from it, center mass will definitely go toward the larger mass, means this side, anywhere. I have taken this point at this position. Suppose that it is C1. I want to find out position of C1. So for this, मान लीजिए mass of the total body is capital M, mass of the removed part, we have removed it, its mass be small m. Then for example I calculate x com of the residual part of the body. For example, this part, after removing it, this will be equal to total mass of the body when it is complete, then its x coordinate of center mass is the x of the C point minus small m, mass of the removed part, into x1, its center mass at this position, divided by total mass of the body minus small m, mass of the removed part. Similarly in y com, z com. Okay. So how the center mass shifts? We will, after removing some part of the body, the very important concept. Let us take one example. It is uniform disc of diameter 56 centimeter. From this disc, one diameter of the 42 part is removed, and I want to find out position of the center mass of the residual part. Again I have taken center of the bigger disc as the origin, x-axis, y-axis, mass will be in the proportion to the area. So x com, center mass, will shift this side of the residual part. So x com of the residual part will be total mass, मान लीजिए सिग्मा इज द मास पर यूनिट एरिया, सिग्मा इंटू पाई इंटू 28 स्क्वायर इंटू 0 माइनस पाई इंटू 21 स्क्वायर इंटू सिग्मा इंटू इट्स पोजिशन विद रेस्पेक्ट टू दिस. रेडियस कितनी होगी? इट इज 28, it is 21, this will be 7. So coordinate will be 7 of the removed part divided by total mass, sigma into pi into 28 square minus pi into 21 square into sigma. If you simplify it, you will get 21 into 21 into 7 divided by 28 square minus 21 square. If you simplify it, you will get it is 7 into 49, cancel, this is equal to minus 9. So x-com of the residual part will be minus 9 centimeter, y coordinate will be 0. The position of residual part will be minus 9, 0. So residual part का center mass इधर shift हो गया 9 centimeter from the complete. Clear? Okay. We take one more example. When some part of the body is removed, how the center mass shifts. Okay. It is uniform disc of radius r. From this disc, a part of radius r by 2 is removed. Now I want to find out position of the center mass of the residual part. Definitely due to symmetry, center mass will shift this side. I want to find out its position. Okay. For simplicity, I take C as the origin, x axis, y axis like this. Again, the masses will be in the ratio of the areas. X-com of the residual part will be total mass sigma into area of the complete disc into 0 because I have taken origin. So minus pi into r square by 4, the removed part radius r by 2 into sigma into its coordinate of center mass x coordinate with respect to c. Clearly it is r by 2. It is r by 2, 0 divided by sigma pi r square total mass of the body minus mass of the removed part sigma into pi r square by 4. If you calculate it, you will find minus pi r square sigma by 4 into r by 2 divided by 3 pi r square divided by 4 into sigma. So pi r square by 4, pi r square by 4, sigma is cancelled. You will find minus r by 6. So coordinate of this point will be minus r by 6, 0. So it is the position of the center mass of the residual part. It shifts this side. Clear? Okay.